Then if you come to Java, Java is having some limitation. It cannot be used for device drivers and all. Excuse me. Then JavaScript can be used for just front-end development. You can develop web pages using JavaScript. But recently they have started giving support for JavaScript for server-side programming also. It is also useful for server side. It is famously known for a language used in developing web pages, for bringing interactivity in web pages. Now, there is a technology called Node.js. That Node.js is used for developing server-side applications also. Likewise, HTML is for developing web pages. Python is general purpose, but it cannot be used for mobile applications. SQL is just for database, for accessing database or querying the data from the database. PHP, Perl, they are again useful for server-side programming. Now, I have given the overview of some of the languages and their usages. So now, the main important point that I have to communicate here is that, see, learning programming language is different thing. And in my first slide, problem solving is another thing. These two things. Mostly students get confused. They try to mix programming with problem solving. Programming with problem solving. Actually, these are two different things, remember. Learning programming means learning the syntax of a language. So what does a language contains? Language contains the features like data types, conditional statements, operators, then you'll have loops, then functions, classes, so on. These are the things that are found in a language. So when you're learning programming language means you are learning what are data types, what are operators and all. If you have learned that thoroughly in one of the language, let us say C language, then learning Java is not a difficult thing for you. And learning Python is not a difficult for you. So learning any one of the programming language is sufficient. So among these first four, if you ask me which one I should learn, sir, so I say learn Java. Completely, everything from Java, learn everything from Java, focus on that. All right. Now, one more important point. If you are learning Java in your second year, first semester or second semester, if it is there as a part of your course, then you should learn Java in that semester only. Not just the syllabus given from the university or not just mugging up the solutions given by your teacher, but you should learn Java and become expert in Java within that semester only. Usually, a semester will be of 3 months. So in that 3 months, if you have 3.5 months or 4 months, whatever it is. So in that semester, if you have one language, means you should get master in that semester only. If you keep it pending, then you have to do it after completing your engineering. All right. So if already Java is completed, now still you have a time. In this semester, apart from your curriculum, apart your syllabus, you can also continue learning Java by yourself. If you learn C, C++, okay. And second thing, you can pick up a C++. You can pick up C++. Java or C++. C++ will be a little tougher on side. Java will be damn easy. So you can easily learn all the concepts of programming from Java. So syntax and the concepts are related to programming. This is what you have to learn. Next, I'll go to the third slide. I'll go to the third one. Now, next is, like, student thinks that if suppose I am teaching C++ to you, I have a course on C++, or I am conducting a classroom session, right? I am teaching C++. You think that I should teach you teaching you actually programming means I am teaching you what? Just syntax, how to write conditionals, how to write use operators, how to write loops and all. I am teaching this thing, but problem solving is a different thing. I cannot teach you problem solving. Now, most of the students, like there is a hype, there is a trend going on that is competitive coder. Coding. Now, most of the students ask the question, how to become a competitive coder? So there is no answer for it. There is no answer for it. If you are asking this question, means you can never become competitive coder. That's what I believe. A competitive coder, he knows already everything. Then he will simply smoothly move into competitive coding. Now, I cannot teach somebody, pick up somebody and teach him, this is how you should learn competitive coding. No. Why? Listen, reason I am telling you. Competitive coding is related to problem solving, not related to programming. It is not related to programming. It is related to problem solving. Then how actually the problems are solved? Do we need programming for solving the problems, or do we need mathematics for solving the problems? What we need for we need mathematics for solving the problem. How good you are in mathematics? Now, if I ask like 100 students, 300 students are there, if I ask how many of you hate mathematics, definitely more than 250 students will raise their hand, we hate mathematics. So if you hate mathematics, you cannot become competitive coder at all. If you're saying I hate mathematics, then till now you have reached engineering, means just you have cleared the mathematics subject. Just clear them for the examination purpose. You have studied them, but you have not really tried to learn the subject. So the point here is that I have listed all the subjects here that will help you develop programming, problem solving skills. And if you have taken mathematics seriously up to your 10th standard or even in engineering, then you are comfortable mathematics. Then I can teach you competitive coding to you. I can just guide you, because learning problem solving is a lifetime effort. It cannot be taught in 2 months or 3 months. It's a lifetime effort. Imagine in your most of the universities offer mathematics subjects like maths 1, maths 2, maths 3, maths 4. Like in South India, we have four subjects they have in mathematics, just in mathematics. So already up to 12th standard, you will be learning mathematics. Then what is the reason again teaching same mathematics? And most of the topics are just like revision, like probability, statistics, and calculus, differential equations. Like these topics are mostly revision, and discrete structures also. Some of them are a repeating topic, revising. Why they are revising all the same thing once again? What is the benefit? So most of the students don't find its usage. They feel like it's a burden on them. But actually those are the subjects that actually teach you how to solve problems. Your brain, your mind will get trained in solving the problems. So when it comes to competitive coding, you start doing it by yourself. Nobody has to teach you. Just somebody can guide you, that like do this first, do this next, do this next. They can guide you. Like I am guiding you that first you make sure that you know any one of the programming language. This is the first thing. And once you know programming, when you can write the code, any type of code by yourself in some language, then when it comes to competitive coding, you pick up any problem and you can start solving it. Because solving a problem doesn't require a keyboard work, it requires a pen paper. It requires a pen paper. You have to use pen and paper for solving the problem, not the keyboard. Once the problem is solved and you got a clear idea and you got an approach for the solution for the problem, then you can start coding it. You can start coding it. That's it. So problem solving, for getting good grip in problem solving, please focus on these subjects, and how to study this subject, I will tell you. For every subject, you'll find videos available online in the internet, in YouTube. A lot of people have published their contents on various subjects. So you find the videos. So try to watch the videos first. And then you may find some simple notes or PDFs available in internet, like notes. So follow that notes. Then third step, you pick up a known book, a famous book for all these subjects. Whatever the subject is there in your semester at that time, okay? Pick up the famous book or prescribed book from the university, pick up that book, and you go through that book page means you should be much familiar with that book. Spend more time on book. So try to study the subject from the book itself and make that book your friend, right? So even after 5 or 10 years also, if you just look at the book, you can recall everything that you studied. So studying from, I don't believe the new generation is learning from the videos only, but that is not a good source. That's not a good source. That is just for getting awareness. Just getting awareness. You have to do pen and paper, use pen and paper. Unless you do that, you cannot learn by yourself. All right. So when you study something from from videos or from video courses, the next thing you should learn from the book also. All right. So this is about the problem solving. You can just look at the subject names. I have not I'm not reading them out. You can read it for yourself. Mathematics subject, probability, calculus, and lastly, compiler design and numerical analysis. These are the subjects that help you in learning problem solving. The next thing, computer science concepts. See, you have one problem, you have solved that problem using mathematics, and you have a solution. Right? Then this solution you will convert into a program. Convert into program. Now this program runs upon what? This program runs upon operating system. Operating system runs upon what? Your hardware. And your hardware may be connected to network also. Your hardware may be containing database also. All right. So now you can see this. Once again, you have a problem, you solve it using mathematics, you have a solution, then you have converted that solution into a program. Now, if you see from this side now, a hardware contains a disk or a database, files, and network connected. And then over the hardware, operating system runs like Windows or Linux, Windows operating system or Linux operating system. Then upon that, your program runs. So you should know where your program is running and how a program can utilize network services, how a program can utilize storage services. The program should know how to utilize the resources available on the system. So this is your computer system. Right? Related to this computer system, there are a lot of subjects again in your engineering, like computer organization and architecture. It's related to the hardware. Digital logic design, that is related to the hardware. I write down here. It's also related to hardware. Operating system, that lies in between your program and your hardware. So you have the subjects like some university, they offer operating systems. And again, in final year, they will have advanced operating system. Then, okay, one thing I missed in this hardware part, that is main memory, RAM. I will write it as RAM in short here. So that is also part of your hardware. How to utilize RAM for storing your data is data structures. Then there is network programming, software engineering, and computer forensics or computer graphics. These type of subjects are taught in your engineering. So every subject is important. You cannot ignore, you cannot take any subject easily. Now, one important thing. Okay, on this subject, how to prepare this subject? Same way. Watch YouTube videos, okay, get the notes, study from there, then pick up a book. Finally, you should learn something from the book. You pick up the famous book or the prescribed book from the university and study from that. All right, the same way. For all the three things, you should follow the same approach. Just get the idea first from the videos, lectures and all. Then next, you prepare from the book. Now, okay, problem solving. Second one, this one is there, right? I was talking about this one. Now, learning all these subjects is as important as other ones, because unless you understand your computer system, how you can write the programs? So you should understand your computer system. All right. Now I have three elements here. One is problem. Next is program. And one more is computer system. Problem solving, you need mathematics. Mathematics, physics, whatever it is. So wherever math is applied, you need that one. Then next thing is, for converting this solution of this problem into a program, you need to learn any language like C, C++, any one of the language, and you should know the syntax. That means you should know the syntax, how to use it. Then where you are using it over a computer system, you should have the thorough knowledge of computer system. So these are the subjects related to your computer system. All right. Now, one important thing I'll tell you. See, writing the exam and clearing the exam is one thing. Knowing the subject is another thing. Knowing the subject is different from writing the exam. For writing your exam and clearing the exam, just one day preparation is sufficient for most of the students. But for learning the subject, you have to spend a lot of time on learning the subject. All right. So apart from your college hours, whatever the college hours are, rest of the time you should be spending in preparation only, right? Learning only. Now at college itself, there are a lot of activities for entertainment, enjoyment happens at the college itself. Then if you do the same thing outside the college also, it's useless. So at home, we should spend much of your time in studying all these things. So as you are in first year and second year, I have shown you the importance of these. Now, is it not possible, like some question, like one of the question I just raised here? Okay. Why engineering colleges are teaching all these subjects? Why can't they just teach, I'm using this slide here. Why can't they just teach first semester C and C++, then second semester Java and Python? Then next they teach cloud computing, right? They teach cloud computing, then they teach Android. And then next they teach AI, what is AI and machine learning. Can't they just teach these things because these are the things very hot? Actually, these are all technologies. These are all technologies. And if you want to learn Android, just 1 or 2 months is enough. You don't have to do 4 years of engineering. All right. And if you take your engineering subject seriously, then all these are nothing. See, as a student, when I was a student, we learned Perl. We learned Perl. Not even C language. Even C language was not there in our syllabus. Just one subject called programming languages was having 5th unit as a C language. And even there was no lab for that. There was no lab for that subject. Later, they introduced lab for that subject. So the language that we learn is different. Right. So nowadays, the other languages, advanced languages are there. So just imagine a person who studied Perl in his college. Now he can teach anything or he is understanding everything. How it is happening? Self-learning, self-learning. Now coming to the next point. When you go for placement, do they ask you about all these latest technologies? Unless and until you have done some specialization in them, they will not ask you all these things. They will ask you the basic concepts from these subjects only, from this one and from this one, from these subjects. They ask you questions from these subjects. I'll just remove it, clear it off. Now, why the companies ask the questions from these? Why they conduct interviews from these subjects only? Why they do? They want to know, are you a good learner or not, self-learner or not? If you are a good learner, then the companies will hire you and they will train you. On job, you will get trained. They may conduct a special training session, or also by working along with your seniors, you get to learn the things slowly. See, a fresher who have just passed out, we cannot expect a lot from him. We cannot hand over a big project or crucial project in his hand. We cannot hand over to him, right? So then fresher should be what? Fresher should be a good learner. So if he have learned these subjects thoroughly, if he has taken these subjects seriously, then definitely he will spend. Definitely he can learn at job also. On job also he can learn from his seniors. That is the reason. See, some companies, they don't utilize the things at this core level, but their usage is different, but they ask these questions. They frame the questions from here only. So it is more like Viva. Interview questions are just like Viva. So in your semesters, if you are good at Viva and your Viva examiner appreciates you, then it means you'll get a good job in big company. Definitely. All right. So interviews are more like Viva for freshers. For freshers. And if you miss a chance as a fresher, if you could not get a good job as a fresher, then you have to learn all these things. You have to learn these things. I have listed them. The latest technologies you have to learn. Why people learn these things? That after learning this, they show that I was working on this. They show some fake experience, or if they've joined somebody, like they get attracted to the people, like they will say, we will hire you, but you have to pay us. We will train you in 6 months and give you certificate also. We will give you experience certificate also. and then you can join any company. So that's how people are, means they are doing the business like this. So some people are caught, some students are caught into those hands also. So the reason is they could not get a job in just after final year. The reason they were not good at these subjects. They could not answer the questions from this subject and also the programming subject. Nobody asks related to mathematics. They don't ask questions related to mathematics, but they definitely ask the core subjects of computer science. They ask the language related questions, right? They want to see how much you have. Somebody has raised hand. Yeah, tell me. Somebody has raised hand. Do you want to ask any question? Am I audible? Yeah, Ankit.
Yes, sir, you are audible.
Ankit Kumar. Vivek Verma, do you have any question? No? Okay, let us move ahead. Acha, you have written the question. Do I have to check chat? Sir, one doubt. That okay, I will be attending all the maths classes, all DBMS lecture, all OS. But sir, what is the use of physics in our placement? Because you have mentioned physics. Very good question. Okay, wait. Don't flood with the questions. Let me answer this. Okay, unmute. Who is asking this? Gaurav. Okay. Any more question? Recording on. Okay. Oh, sorry. Computer networks, there is a lot of physics. Yeah. See, physics is involved in your making of your computer system itself. Yeah, networking also physics is involved. Right? Math, physics, chemistry, like these are the three things that does everything. Like when you go to your chip level, manufacturing of chip level, then definitely chemistry is involved there. And how the system is designed, your computer system is designed, the machine is designed, so physics is involved there. So there are many formulas, there are many things there that are just in the form of mathematics only again. Physics in the form of mathematics. So I'm not saying that focus on physics. It is so usually taught in first year. Physics is taught. Why it is taught, I'm telling you. Okay, I'm not saying that leave everything and start learning physics. That is not the point here. Okay. So physics is also taught in South India, like in Hyderabad, most of the universities, they have physics also in first year, chemistry also in first year. What the hell, why they are teaching that again? Because that is useful for all the engineers. Most of the time, first year of engineering is common. So they make everybody study those subjects. So but computer science students, they feel that, computer science students feel that we are into programming only. What is the use of this? So that's what I am saying, that all these subjects are useful for you. They will make you learn problem solving. They will make you learn problem solving. Okay. So let us go ahead. Can you clear the screen? Somebody has written on the screen. Let me check if I can clear it. No, it's not getting clear.
Ashutosh, are you there? Ashutosh, if you can, control the thing.
Yeah. I think it's visible to everybody. Okay. Let us continue. Career options. Now in this, first one is, some of the career options I have given. The first one is web development. Web development, full stack, means front end and back end together. Now in this site, do you require programming on front end? Very little. A lot of tools are there, just drag and drop and develop your front end. Very little of programming is required. Now, do you require programming at the back end? Yes, you require enough programming required at the back end also. So at front end, programming is not much required, but back end programming is required. So here the programming is involved. All right. So if you're focusing on just on competitive coding, or you are trying to become a good programmer, then if you are becoming a web developer, then your job may be writing the programs at the back end. And this backend, today's backend has become a cloud. Earlier, it was just web server or web services. Later on, now presently, backend is nothing but a cloud. So you are doing cloud computing, it means. Now, next is database administrator. This role is related to managing database or administration of database. So databases, you will be studying in your coming semesters, maybe. So I'll just skip a little bit about this one. Data is the core part of your application. Without data, there is no use of application. So data is mostly kept in the tabular form. It is organized in the tabular form. There are more methods of organizing them. So one of the method is that is organizing the tabular form, that is called as relational data, relational database. So relational database. So when the data is organized in the form of tables, multiple tables, and the tables are linked together. Now DBA does now have the knowledge of everything about the databases. All right. So I can just tell you a little bit about this one. So DBA job is related to database. That's enough. Now programmer. Programmer means application programmer. That person is using Android application he is developing, or iOS application is developing, or standalone desktop application is developing. Now one of the role is what? Here also programming is involved. Here also programming is involved. Okay. Now DBA, programming, SQL is required. A little bit of programming is required, not much of programming. All right. So I am telling you the point. What I am trying to communicate here is that no doubt you have become a good programmer. No doubt you have become a good programmer. You have studied the subject thoroughly. You know the language perfectly. But it doesn't mean that in career also you need to write the programs always. It's not necessary, because there are different job roles, and they have some of the job roles require really programming knowledge, and you need expertise in programming. But for getting a job, you should know programming again. So which level of programming you should know? Student level programming only. Whatever you learn in your course, only that knowledge is enough. Right? You don't have to know. You don't have to master in programming. Whatever you learn in your syllabus, that is sufficient for the companies. All right. So overall, what I am trying to say is focus on the subjects. Focus on the subject. See the subjects that are there in a semester is building your career. Right? Yeah. Consistent. Okay. So those subjects are making your career. You don't have to study anything extra other than engineering subjects to get a job just in one attempt, a good job or job in big company in the first attempt itself. Otherwise, you have to struggle with all the other technologies. You have to learn all the things. This one, what I have mentioned here, some of them I have mentioned anyway. Now, graphic designer. Graphic designer is more useful for developing front end of the website. Front end of the website, right? Now, data scientist or data analyst. Nowadays, the internet is full of data. Vast data is there. So, analyzing over that data for solving business problems or giving solutions or giving analytical results. Now, here also a little bit of programming is required. Testing, you don't have to have a good knowledge of programming, but you should have a knowledge of testing. So definitely testing is not taught in your engineering, right? And graphic designing is not taught in your engineering. And in your engineering, they will not make you data scientist directly. Maybe some subjects are there, but directly they are not making you data scientist. But the subjects that you have studied will help the companies to make you work upon these technologies with little bit of training. And you can learn them by yourself, right? So these are the different roles I have mentioned here. And again, game developer, this is a programming part again. Network or cloud architect, programming is not much required. Software tester, knowledge of programming is not much required. but overall knowledge is sufficient. Now imagine, if you are aware, most of the job are for testers, testing job. Many people after completing their engineering, they join testing. They easily get the job there with a package of 1.2 or 1.5 LPA. They get the jobs there. That is the easy and the quickest job. Reason, you don't require much skills there. That is the reason. That is the reason. And while working, then you realize that really this is nothing but a routine job. Routine job. Even without doing engineering, you can do it. So the job should be such that your engineering, all the things that you have learned should be useful. If you once, if a person is doing a job and he feel that unnecessarily I learn all those subjects in engineering, means he is not working as an engineer, definitely. Now coming to the next. Yeah, this was the topic actually. In the beginning, this was the topic. And that is data structures and algorithms. This was the topic. So I have little time, just I will tell you brief on this one. Somebody is writing on the screen. Can you please clear off? It's gone now. Thank you. Thank you very much. Yeah. See, data structures. Now, what is the importance of data structure? That I'll explain you. See, I have shown you this diagram. Okay, from the top, I will show you now. This is a program. This is a program. Program runs over the hardware. And this is OS is there in between. So program is running over here. Now hardware involves main memory also. Main memory. Okay. The program runs. The program runs when it is loaded inside the main memory. When it is kept inside the memory, then only program runs. So program runs over the hardware. All right. Over the hardware. Now a running program in the main memory, when the program is running, it uses data, because program is nothing but step-by-step procedures that is performed over the data to get the results. Step-by-step procedure for that are performed over the data to get the results. I am giving this definition now, right? So program is a step-by-step procedure. If you ask what is algorithm, that is also a step-by-step procedure for writing a program, for solving a problem. So program is also a step-by-step procedure. There is no use of procedure if you don't have data. If you don't have data. So program definitely requires data. Program contains two things. Now program is equals to, I say like this, program is equals to instructions plus data. Now program, where does the program run? Inside the main memory. I'll draw a bigger picture here. Inside the main memory, program runs here. All right. So inside this main memory, program is there, and also your data should be available inside the main memory only. Inside the main memory. So during the runtime of a program, how the data is organized inside the main memory, the arrangement of that data is called as data structures. Arrangement of that data is called as data structures. So the data that is used by program is called as data structure. So a data structure is a core part of a program. Without data structure, there is no program at all. There is no program. It's a core part of the program, data structure. So if you don't know data structure, it means you don't know programming. If you are not good at data structure, it means you don't know programming. Because, see, okay, next I will show the slide. This is the last slide. Now, these are the algorithms. What are algorithms? Algorithms are nothing but the procedures for solving the problem. I'm not going to teach you all these algorithms. Just I have given a list of algorithms, types of categorization, and names are there. So these are the problems. Algorithms. Algorithms are the step-by-step procedure for solving a problem. Now, why we say algorithm? Algorithms are not written using some programming language. Algorithms were existing before computers came. Algorithms are existing from thousands of years. Right? Algorithms are already there for solving the problems. Those algorithms were nothing but in the mathematical form. Right? Mathematical formulas were there. Now, when computer came in, we started converting the known algorithms into programs, converting algo to a program, algorithm to a program. Now, what is required when you are converting an algorithm to a program? The steps in an algorithm, sorry, the steps in an algorithm become instructions of a program. Then the data utilized in this algorithm becomes data structure here in the program. So without a data structure, you cannot solve or you cannot write any algorithm. You cannot write any algorithm. All right. So data is very important. Now I'll give you some idea. Here you can see that one of the problem I'll pick up. Prim's algorithm. Prim's algorithm. This requires a graph. How do you represent a graph in your computer system? There's a connected graph and the vertices are there. 1, 2, 3, 4, 5. These are the vertices and they are connected like this. How do you represent this? This is on paper, but how a program can see if it is on paper, then you can use an algorithm for solving it. Who will follow this algorithm? Human. But program, your computer. See, I'll make it simple a little bit. Let us understand this. We humans can solve the problems using pen and paper. We humans can solve the problem using pen and paper, right? Then we define algorithms which are used for solving the problem. So definitely those steps are done on pen and paper. Same thing we want our computers to do that. So we should give this data to the computer system or to our program. If you want our computers to do the same thing what humans are doing, then you should convert this algorithm into a program. And the program needs this data, definitely. So without data, there is no use of program. How you organize the data? You use data structures. Here are the data structures. Like I have shown you one graph. So graph is there here. All right. Now just you see the names of the data structures. These are the data structures that is taught in 2-1 or 2-2 in most of the universities. And if you have not learned data structure, still you have a time. Still you have in the time. You have vacations also in that. You can revise all the subjects that you have missed them. Every subject is important. And the bottom line is that, I end here, the bottom line is that every subject in engineering is important. So take it seriously, you don't have to worry about the job. And even if you don't get a job, you can create jobs. You can create jobs. If you know the things, then you can create the jobs. Otherwise, see, one more point I'll tell you. Those who know how to work for themselves, they can create jobs. If you don't know how to work if I don't know how to work by myself, then I need somebody's shelter. I will look for the job. That's one. So we stop here. If you have any questions, you can ask. Hope you have enjoyed the session.
Thank you, sir. From the audience, if anybody is having questions, please you can put it on the chat. If any question more